Hi, this is From Chaos to Resilience, Decoding the Secrets of Production Readiness. My name is Alejandro Pedraza. I'm a software engineer at Buoyant, and I'm one of the maintainers of the open source project Linkerd, which is a service mesh hosted at the CNCF. These are some of my social media handles. I'd be happy for you to contact me if you have any questions or for anything else. Why am I solely focusing on Kubernetes? First obvious reason is because I work in a project that specializes itself in Kubernetes, but also I firmly believe that Kubernetes has a well-earned place as a de facto standard. Even before Kubernetes, more than 10 years ago, you might remember Heroku, which was a godsend for people wanting to quickly deploy services at scale without thinking that much about infrastructure concerns. The Heroku developers came out with this document called the 12-factor apps, where they listed all the aspects to take into account to have a successful production deployment. Things such as configuration management, log management, also code as the single source of truth, something that today we would more or less call GitOps, and a lot of other things. Kubernetes has managed to acquire all that and offer it in its framework. So when you build on top of Kubernetes, you can be confident on building on top of a very solid base. From a DevOps practitioner point of view, it's good because you don't have much risk of learning and having experience on something that will be quickly forgotten, which happens so much in our industry with programming languages or frameworks. Also, from the other side, as a company, it can be seen as easier for hiring. It's easier to know exactly what you're looking for, Kubernetes knowledge and expertise. And also another benefit of having a standard like that is that as a company also, you're able to more easily switch between providers. Currently we have 3 major providers, GKE, EKS, and Azure, which are very similar. They do provide customized functionality that you should stay away from as much as possible, so you can more easily switch between providers. And there's also a bunch of other providers that offer different things, like I can think of DigitalOcean that's supposed to be cheaper, and etc. etc. Now let's talk about service mesh. Kubernetes is first and foremost a container orchestration framework, which means it's great for deploying containers at scale. It makes sure that containers are properly distributed in your cluster. It makes sure that they acquire the proper amount of resources, CPU and memory, and it makes sure that those containers can connect with one another. But from a networking perspective, it only goes generally up to layer 4, which means it only knows about IPs and nothing else above that layer. So if, for example, you want to declare access policies between services, you would use something like network policies, which only talks about IPs. And as you know, IPs might change. And so at the end of the day, this is not a very great abstraction to rely on. And so to go further, to fill up this gap and other gaps in Kubernetes, you have to rely on other projects, and a category of those projects is service mesh, which Linkerd makes part of. And so how does this work? In particular, Linkerd uses the sidecar pattern. As you know, in Kubernetes, the minimal unit of work is the pod, where you can put one or many containers. And when you use Linkerd, you would inject a proxy container in your pods, you are encouraged to do that in as many pods as possible. You shouldn't be worried about the resource consumption that this would imply, because Linkerd is very minimal and secure, as I'll explain in a moment. And these proxies take over the connections, both inbound and outbound, in these pods. So at the end of the day, the connections between your microservices in your clusters happen between all those proxies. And so they end up in a privileged position to know exactly what's going on in your cluster. And so it can provide you with extra security, a way to observe what's going on in the cluster, and also provide primitives for you to declare how the services can connect with one another. And also, the DevOps philosophy is to empower developers so that they are more responsible about how to deploy their services. And service meshes help with this by providing an API where developers can declaratively say how their services are to be exposed in the cluster. They can declare their access policies, their reliability characteristics, like can a given service be retried, what is its timeout, etc., etc. Let's talk about the first pillar of service meshes, which is security. The most naive approach to security in Kubernetes clusters is to secure the boundary of your cluster. If you have a single point of entry, that would be through an ingress, so you would provide TLS termination for that ingress and maybe provide some firewall rules, but this is not enough. The bigger your cluster is, the more dependencies you rely on. It's not uncommon for a single service to depend on dozens of dependencies, be that open source or closed source dependencies. And if any of them becomes compromised, it could compromise your pod, and your pod can become a source of attack within your cluster. And it wouldn't matter that you would have secure only the periphery of your cluster. So this is where zero trust comes in, and the recommendation is to narrow down your security perimeter as much as possible, even up to the level of the minimal unit of work, which in this case is the pod. So this is why Linkerd still defends the sidecar model, which again means having a proxy in each one of the pods. That proxy is going to provide security for that pod. There are competing service meshes approaches, which are now using only one proxy per node, but we believe that is a less secure offering, and it doesn't bode well with the architecture that Kubernetes offers. How is that security provided? When you inject a Linkerd proxy, all the connections between services are MTLS'd. What is the MTLS protocol? You're familiar with the TLS protocol. When you browse a website in HTTPS, you know that the identity provided by the server is cryptographically verifiable, but it's not the other way around. The server doesn't know for sure what's your identity, and if you want to provide that, you would need to do that up the application layer through some sort of logging mechanism. And MTLS or mutual TLS does that both ways. When you connect to a server, you can verify its identity, and the other way around, the server can verify the identity of the client. And that happens automatically with zero configuration. If you would have to implement this yourself, it's really difficult. There are many things that you need to take into account, like the provisioning of the certificates, managing the identity provided in those certificates, rotate those certificates as much as possible, etc. It's really complicated, and this sidecar service mesh gives you that out of the box with zero configuration. I also promised to talk about why Linkerd doesn't require that many resources. Linkerd is, the proxy of Linkerd is reading the Rust programming language, which is nowadays the recommended language if you're interested in performance and security. Who is not? I acknowledge that there's an initial learning curve for Rust, but it's well paid off with time. Rust doesn't rely on a runtime garbage collector. You have to manage memory yourself, but the programming language gives you an abstraction to do that declaratively, so it's not that complicated and not error prone as it would be in C++, for example. And the compiler gives you guarantees that you're doing things right. Improper memory access is one of the security vulnerabilities that that any process can have, but studies have shown that that is by far the most frequent vulnerability. So if you have your memory management checked, you've come a long way on providing a secure system. The second pillar of service meshes is observability. I understand this is not a high priority in projects as opposed to, say, feature completion for obvious reasons. But if you don't have a complete observability stack along with an alerting system sourced off of data from that observability, you cannot have a service that you can rely on. You cannot have a precise aggregate view of how your customers are experiencing your service, and if something goes wrong, it might be too late when you realize so, as opposed to having a properly configured alerting system that will give you enough time to react to problems. As I said before, the Linkerd proxies benefit from a privileged position in the cluster. If the more pods they're injected in, the better view they will have of the system. Each proxy exposes a metrics endpoint with mainly network-related metrics that can be scraped by Prometheus, so you can have a view of each one of the workloads, or you can aggregate all this data and have a more holistic view of your system. Linkerd also offers an optional Linkerd Viz extension that comes with a pre-configured Prometheus instance that scrapes all the pods. It also has a dashboard that where you can see, for example, how connections flow amongst many dependent systems, many dependent services. So you can see what service is causing trouble in some situation. And we also provide some charts so that you can use Grafana to visually see all this data. But the recommendation, this Linkerd Viz is sort of a proof of concept, and the recommendation is really for you to provide your own Prometheus instance that is scaled properly to your needs. But to go further, also, I'd like to plug the Buoyant cloud offering that we have, which is a managed Linkerd service, thought more for production level usage of Linkerd. The third and final pillar of service meshes is reliability. You should not design your system around the optimal use case. The bigger your cluster becomes, the more likely it is that something is going to fail, and you should prepare for that. Thankfully, Linkerd exposes some primitives that you can use to declare how your services behave. For example, you can say whether a service has a timeout, whether it can support retries and to what extent. And also, we embrace the continuous deployment philosophy through progressive delivery. So you can for example, deploy a new version of a service without disrupting customer experience by little bringing up the new version of the system, by diverting traffic progressively, and at the same time inspecting the metrics of that new version, and if everything goes well, divert more and more traffic until everything is diverted to the new version of the system, of the service. And if we see a problem in the metrics of that new service, revert the process so that the former version of the system is the one that continues to be served. This was all that I had for you today. I hope this was useful in your journey towards providing world-class production-ready services. If you have any questions, I'd be happy to answer at this plain old email, or please visit the linkerd.io site where you will find plenty of resources. Thank you.